Thank you. Okay, I hope you have enjoyed the talk. And now for the second half, I'll do a quick intro for Mina. Mina Khan is a senior research scientist at Google DeepMind. She works on reinforcement learning for large language models in Gemini. Mina had her PhD at the MIT Uni, where she researched intersection of artificial intelligence and human-computer interaction. Her bachelor's in mathematics, physics, and computer science. She hopes and strives to use AI to solve real-world problems. And without further ado,
Thank you. Thank you for the introduction. So, hi everyone. I hope you're enjoying the session so far. I heard someone mention Move 37 here. Can you tell us more about it?
Yeah, so Google DeepMind was playing a game against the world's the champion of it was what was the name of the game? Yeah, of the Go. So the name of the world champion was Lee Sedol, and so the AlphaGo played a move. It was called Move 37, and everyone got surprised. All of the people who know Go, they got surprised. Like a human would never play this move, and it is still a surprise. But that move actually led to AlphaGo win the game. That's about it.
Great. I'm glad you know about it. Does anyone else want to share about how they got to know about? Was this the first time you got to know about reinforcement learning or no?
Yeah, actually, it was from the documentary that Google DeepMind
Mhm.
published. It is a documentary, and I would highly suggest everyone to watch it. The AlphaGo.
Your speaker suggested you watch AlphaGo. I did not. But I think that was also one of the places like I got really excited about reinforcement learning. And I think I'm in the same boat as you. I think a few years ago I was sitting there. So like feel free to stop me, ask me questions. This talk is supposed to, I think, ideally inspire you, give you a higher level view, give you some intuition so you can go play and explore yourself. So we'll talk about mostly reinforcement learning for large language models, which are very popular these days. I'm sure, has anyone not used like ChatGPT or Gemini or Claude so far? It's okay, you can raise your hands if you haven't. But if you have, you have probably used this technology in real life. Um, so this is what the outline looks like. Like I said, I'll try to give a higher level, intuitive, like landscape view so you can like explore yourselves. We'll talk about why should we even care about RL, what it is in the simplest possible sense I can describe, and then like how to do it, like what are the different components you can tweak and play around with. So why? I think like this is the most important question I think you should ask yourselves whenever you do something, like why should I even care? And we spoke about ChatGPT. I don't know how many of you know about the Instruct GPT paper. Can you raise your hands in case you know? Okay, great. Sorry? Instruct GPT. Yeah. So in that paper, they showed that like a 10 to 100x smaller RL model can match or beat the performance of a supervised learning model. So imagine the power of reinforcement learning, that it can like teach a small model to do something that was competitive compared to a big model. Um, and can you like, can someone explain why like that could be possible? If you, please feel free, like all answers are okay. You don't have to be right. Can I pick on someone? Can I ask you? I think you're hiding your face. Do you know like why, what is reinforcement learning for you? Maybe I'll explain it too, if it's okay. I just want you guys to be comfortable, that's all.
Could you repeat, please, your question
Yeah,
again?
like, why do you think like this result happened? Like, what is reinforcement learning to you, if anything? Like, why do you think like a smaller reinforcement learning model could match or outperform a supervised learning model?
Reinforcement learning is used like to align the model with and for what I know is reinforcement learning is used to align the models with the human feedback.
Yeah,
LLMs.
that's a great answer. That's very spot on. It's supposed to align it with the human feedback. And what does the feedback look like? Yeah, right, positive or negative. So, I mean, I think you all, yeah, perfect, perfect. Yeah, so that was the first point here on this slide is like, I think very similar to how humans learned. I think it would be a shame if we only learned from the positive examples, right? We learn from our negative examples as well as positive. So like one thing reinforcement learning does is like, it teaches from both positive and negative examples. And then another thing is like, it can learn from its own experiences. So with supervised learning, you have a fixed distribution, but with RL, like you heard in the previous talk as well, like the distribution can change because you're exploring in the real world. So like, for example, if the model saw a new move, it could like actually see if it like led to a win or loss. But if maybe it was learning from human data, it could have not even seen that move there, right? So I think these two important factors lead to it being a little more different from supervised learning. So what is RL? I think there, like when you start reading textbooks, at least like I personally found there was a lot of information, and I just wanted to simplify it to like, what is reinforcement learning? Like, what are the different bits? So one of them is an initial policy you start with. In the LLM land, it's usually a supervised learning policy. It gives you a good target distribution to start with. You can think of it as almost like you have read the textbook, and now you're going to answer questions which will be either right or wrong. So you'll start with some basic information, but then you'll like try more like question and answers. Then you have a reward model, which teaches you if something is right or not. That's the one giving you the label, right? So right or wrong. And then the final thing is the optimization bit. So I think, and the reason these things are important is like, I think once you're training a reinforcement learning model, like you can tweak each of these knobs, and like your reinforcement learning algorithm would change. So let's go into that deeper. I think, how many of you seen this picture on the left? It's a very standard picture people draw for reinforcement learning. Yeah, I feel like some of you just know more than me at this point. So there's an agent which takes an action in the environment and then gets a reward and sees the state of the world. So like, I think these are the different components that go in. There's an action, state, and reward. And then like, there's an environment in which the agent is acting. And we'll go into each of these components in depth. So again, so you get a broad landscape view of things. So I think the reward model is really important. Like everyone asks, like, where is this reward coming from? And you said like it's supposed to align with human feedback. And this is another paper from Anthropic on like helpfulness and harmlessness assistance. And there they showed like this preference model training of using reinforcement learning, where they are like, ask a human which one of the responses is better, and like if A is much better than B, and how much of it is what's the scale of betterness, and that's what it means to align with human feedback. But you can have something more than human feedback as well. So for example, you can have from AI feedback itself. So in this case, instead of the human, you can have an AI in the loop. So instead of a human rater saying this was better than that, you can have an off-the-shelf LLM giving ratings to like this was better than that, and then train the model based on that. And then another example is you can have reinforcement learning from execution feedback. How many of you have heard RLEF, for example? No? Okay, I'm glad I'm teaching something new. But so in execution feedback, imagine now you're doing coding problems, right? When you're writing code on your computer, the way you learn is like you execute it and you see what the output is. I think it's a very similar thing for like if you're teaching a computer how to, like an RL program how to code, you can learn from the code's execution. So you can pick your like favorite reward model and start training the model on it. So it can be AI feedback, human feedback, execution feedback, anything which is a good reward model, like I think like you can test it. So these are like the 3 different flavors of like the types of reward models, and there are many more. You can like explore it. Okay, another type of reward you can give, and I think so Dr. Sanjay mentioned about credit assignment and how I've seen it being referred to as the process supervision or outcome supervision work. How many of you know about this work? No? Great. New things again. So one way of like, so if you saw this one, like here, the model was getting a reward in the end, right? So it's like, this one's better or that one's better, but it actually doesn't know what led to it being better, right? Like, was it because like it had better formatting, it had better something? So if you see here in this question, for a math question, it specifically points out not just right or wrong, but what is wrong. And that is called process supervision compared to outcome supervision. And they applied it to some math problems and showed it has like better performance. So that can be another. So in the first few examples, we talked about the source of the reward, but then you can also vary like how do you give the reward, right? Like the reward can be seen at per step or like in the end. So this is, I think we've touched a little bit on the rewards. Now we'll go towards more of what's the action space. And I think Dr. Sanjay again mentioned chain of thought. And I'm sure you have read about O1, R1 style models so far. I think it's, the news is making my talk easier. So I think it all, like, for me at least, it all started with this paper, Let's Think Step by Step, where instead of having the model like get to the answer, they ask the model to reason about it and then get to it. So it's almost like a 2-stage process where the model is like asked to reason about it first and then get the answer in the end. So just like forcing the model to have some like thought process before getting to the answer. And then another follow-up work is this STAR paper, which is self-taught reasoner, which I think built on top of this work, I think. And in this, what they did is like, so they had the model reason and come to the solution. But then if it came to the right solution, they would use it to train the model. But then if it came to the wrong solution, they would further like augment it to boost its own knowledge. So the reason it's called self-taught is because the model is getting to the answer and its own right answers are used to train the model. Right, and then the wrong answers are like further augmented with like hinting and rationales and used to boost itself. And I think we spoke about this briefly as well, the R1, O1 style thinking models. I think the thing to see in this trajectory is it started with like a simple step-by-step, but then like more and more work, and now like these models are able to solve really hard problems, including, like, I don't think I can solve a lot of Amy problems. These are like really hard math problems. So I think the thinking actions have been used to like really augment the reasoning capabilities of these models. Questions so far? No? Still following, kind of? Okay, great. I think we're coming towards the end, and then we'll have the open questions. But one thing I wanted to like bring is we started this talk with like, hey, how many of you have used like ChatGPT, Gemini, Claude, which are more like they are answering your questions in terms of text. And then we spoke briefly about AlphaGo, which was a completely different environment from text. But you can think of many more environments where this could be applied. So like you can have a different reward model, you can have different actions, but you can also have different environments. So like, I think another like early on paper was this WebGPT paper, where this model wasn't just answering questions, it was actually looking up information from the web and like extracting bits and using that information to actually craft the final answer. So like, yeah, I think, so another, I don't want to go into too much depth here, but I think they similarly taught the model to like look up things and like reference things from the web. And the final one, I think, is this computer use environment where I think this is probably getting, I think getting more and more popular, that your agent is also interacting with more things. So not just like talking to you, but like maybe like using your terminal. And I think I see a lot of you nodding, so I know you have seen examples for it. Have you used it?
No, because it's not free.
It's not free? Good point, good point. Oh, what's not free?
This service, like ChatGPT, OpenAI released some service files.
Yeah.
Yeah.
Yeah, I think so. I mean, I think again, going back to the bigger picture of like what is RL, I think we apply it on a daily basis. So what it is should be very intuitive to you. You learn from right or wrong examples, you learn from your experiences, you get rewards, you have an environment you're operating in, you take different types of actions in that environment. And then I think going back to the move 37 of like the importance of creativity, and I think with those like ingredients, I would really encourage you to think about like what are the different environments and action spaces that you can like use to improve, like that a model can engage in and improve there. But yeah, it's something as simple as that, and you can start there. That's mostly what I had. Do you have questions? I think I finished right before time.
So hi, thank you for the talk. I have one question about the reinforcement learning from the AI feedback. In the training the model phase, for example, there can be data repetitivity after a while. For example, we feed model from the data that AI produced, and afterwards, that producing data can be fed back into the model as well, and that became a problematic afterwards. For example, in the future phases, we might be fact-checking the data itself as well in the afterwards. Also, in the current state of models, we can distinguish from the model's response very quickly whether it's AI generated or a human write the model. So what do you think about those topics? For example, data monopoly in the future. I mean, the data produced from the AI models with reinforcement learning. Also, yeah, I guess that's it for now. That's the question.
Yeah, I think that's a great question, especially because I think data is usually very important, and it's good to like think about it. I think with opinions, I think I try to like have my opinions backed with like research or facts. So one thing about like AI feedback is that, I think going back to the RL-AIF paper or even like Anthropic's paper on constitutional AI, the reason for using that is it allows you what I think the constitutional AI calls like scalable oversight. So maybe you don't have enough humans, but you can have enough like AI to like label it. But like you said, the model can also be biased or have its own problems, inaccuracy. So I think it's good to be mindful of the pros and cons, and then like I think maybe to like further augment it. So one thing we didn't talk, for example, about in this paper for process supervision, one thing they used is like active learning. So like they actively taught the model things it was bad at. So instead of just giving it any distribution, they gave them like specific distribution of things that it wasn't doing well. And then it could further improve there. So I think in general, the answer to your question is data is really important. Using AI to augment data is great because it allows you to scale well. But then I think it should be done knowing that like the model, like it shouldn't be a garbage in, garbage out type of problem, right? Like if the model doesn't know anything.
Yeah, definitely. Because, and currently all of the people are consumers of these AI models are currently getting that data, that output, and put it online from their projects, homeworks, etc., whatever the might use can be. And those data are, we got that data as well and train the model with them. So it's a little bit a feedback, loop. Yeah.
Great question. Any other questions? Yes, please.
Hello, thanks for the great talk. I'm wondering,
how to make sure that we're not sacrificing generalization in order to do some alignment. Sorry, can you repeat that? Is there any trade-off between the generalization and alignment in general? Trade-off between generalization and alignment. Give me a more specific, like, why do you ask the question? I'm wondering, like, if we're, while doing some alignment, we're changing the weights of the model, right? So will this impact the generalization of the model? Yeah. So I think, like, one thing that you may come across is, like, I think with RL sometimes when you are asking the model to fit to it a specific distribution, obviously you're narrowing the distribution. I think the goal in RL is to do it in a way that, like, it sticks to the right, like, for example, you wouldn't want your model to take the wrong actions, but you ideally want it to also know those actions are bad. So it's I think diversity in RL and exploration is still an open problem you should think about. So there's definitely a trade-off, and I think that's what we put, like, active effort into. Yeah, great question.
I have like a similar question. I
sorry,
wanted
I think
to ask.
she raised her hand first. Can I ask
okay,
her?
okay,
Yeah,
sorry.
Thanks for the talk. My question is about actually the point on exploration, exploitation. What is the best algorithm at the moment? Is it UCB or another one?
I think I wish I knew, sorry. But I don't think there's, so to be very honest, there's no single best. I think best is whatever works best in your use case. You can decide that, and that would also vary, right? Like, so what you should think about is, like, what's the cost of that exploration? How much exploration do you need, etc. So yeah, I don't think there's a specific best one.
I can just mention here that sometimes people use, I think the work that Safa does, like maximum entropy. You know, they add a term in the objective function that encourages exploration. Yeah. So you want to explore more. So you want to, when you learn a policy, you want it to have maximum entropy in some sense, subject to the same time to maximizing reward. So.
Thank you. I think, yeah, go for it.
Yeah, I think I was asking the same question about exploration and exploitation. Yeah, I got it. Yeah.
Awesome. Other questions? I think that's, yeah.
So my question will be about something more practical. So let's say we are trying to, or we are implementing a preference tuned model from scratch. We do pre-training, right, and instruction tuning, and then finally preference tuning. So what will be the, in your opinion, like the simplest baseline approach that we can take? Because there are lots of approaches, right, using the reinforced algorithm, as we said. So what do you think should be like the approach that we can take so that we could understand what's going on better without going or doing advanced stuff?
So is the question, like, what's the simplest way to get started, or what's the simplest for you as a person, or like for like an organization?
I mean, in general, like for let's say we are coming from like similar backgrounds, right? So we know some stuff about deep learning and so on, but reinforcement learning is maybe new to most of us. So, and it's like very complicated topic, involves like many different things. But in here, our purpose is to apply them to LLMs.
Yeah.
And have and do a preference tuning. So, what will be the baseline preference tuning algorithm, in your opinion, that we can start with?
I think so. I have a couple of answers in my head. I think there used to be like like an open gym environment for reinforcement learning algorithms, but that's probably not the most applicable to LLMs right now. I think Anthropic's like HHH paper for me, the one I showed before here, was at least like when it started was a good like I think introduction. So I think because they also have like open source data sets where you can train like reward models, test them. One interesting thing they also did in this paper, they talk about this like preference pre-training, is they actually took a lot of data, let's say, for example, from Stack Overflow, and then compared the answers and like saw which one was better. I'll think about it and probably like maybe if there's a way to get back to you with like specific resources of like what's a good way to get started. But yeah, I think like maybe like find like open source data sets, train on them, find like a training framework and like, yeah, train a reward model, start with some policy. Yeah, but I'll get back to you with like specific resources. Good question. I'll get back to you.
Okay, thanks.
Hi. First of all, thank you so much for the talk. So my question is basically regarding extrapolating reinforcement learning solutions from like a deterministic state space towards like continuous state space. So like I've taken some courses in reinforcement learning, and our basically the projects that we did were like specifically on discrete state spaces. And one of the criticisms for reinforcement learning is like you need a lot of data, and for the real world, we may not be able to extrapolate these reward functions for like, because the real world is not really discrete. It's a continuous space. So even in your research that you have shared with us, I've seen like you're using reinforcement learning with some sort of supervised learning where you somehow try to extrapolate or like distribute the rewards over the continuous space, or basically you go from a discrete space. Like, so for example, if you're going example by example, you are training the model using RLHF, but then again you are getting some sort of like continuous general improvement in the general performance of the RL, right? So my question would be like how would you say we go from such deterministic RL algorithms towards solutions which can work in the real world in the continuous state space? Thank you.
Yeah, I think so there's a lot of work on like discrete versus continuous, and I think like one of the things that comes to my mind is like I think continuous is very relevant in robotics, and there's a lot of policy gradient work applies to like continuous action spaces as well. I think everyone follows like continuous versus discrete action spaces, so like taking a left turn versus a right turn versus like controlling like an actuator which can go from like 0 to 10. So it's a very valid question. And I think they're like for example, I think like policy gradient algorithms have been or flavors of it have been used in robotics. So I think there are instances of it being used in continuous action spaces.
Yeah, so over here I was seeing like RL was being used together with some sort of like supervised learning. So that is my takeaway from this, is like you don't simply just use RL, or maybe you can use the algorithm that you're suggesting. But then also what I've seen in these papers is like you use it in conjunction with existing like optimizations over neural networks. So
Yeah,
that's
definitely.
like a nice takeaway from that. Thank you.
Yeah, of course. Thank you. Yeah.
Can't we teach the model literally like a new task using the alignment techniques? Why don't we use the alignment techniques for the fine-tuning? Basically, I feel like we can use basically the alignment techniques to teach new tasks, since it's a learning algorithm after all. Why don't we really are doing this? Is there any constraint or?
What type of alignment are you thinking of?
Let's say, I'm not really, I don't know a lot about.
No, it's okay. Just like be comfortable. Ask. Like I just want to know what.
I feel like I don't really understand why we have SFT then alignment, while we can do the directly teach using the alignment techniques.
Why do we even need an SFT stage before RL? I think like maybe Dr. Sanjay also mentioned this, but like mostly for like sample efficiency reasons. And I don't know how many of you, like for example, read the R1 paper as well. They talk about it that they tried to just do RL from scratch. And I think then they did another phase where they actually like tried the supervised learning policy before the RL. So it's, I think going back to actually your question of like discrete versus continuous. So whatever we share here is like what's being used right now. We're not saying it should be used. It's more like this is what's being used. But you can try and like do a different thing and maybe it'll work. I think that's why it's an active area of research. I think the reason they do it is for like just efficiency reasons. Like you give it a good enough policy and then it refines that policy.
Question for you?
So maybe we can have like questions for both of us now?
Yeah. So can I ask a question?
Yeah, of course,
I'm here.
Of course.
Yeah, right here.
Hi,
Okay.
sorry.
Thank you for your excellent presentation.
Kind.
I have a two-part question for you. I was thinking in terms of training, applying reinforcement learning when we're trying to improve the behavior of our model. Is it possible to add extra weights like LoRa ideas and freeze other weights and train only those weights that are dedicated for reinforcement learning for that specific task? Is it possible, or we train basically the entire weights of our model?
Yeah, I think, so for those of us, or some of us who don't know LoRa, can you explain a bit of LoRa?
Yeah, so this is not necessarily LoRa, just adding some weights. By LoRa, I mean multiplying two low-rank matrices to basically get a bigger matrix, but with fewer parameters. I mean, but yeah. I was curious to know about the strategy of learning. Are we trying to optimize the entire parameters of the model, or just we add specific weights for that reinforcement learning task?
Yeah, I think like it's definitely a good idea to try. I think again, like all of this is very active research, and I think the best thing is to try and see what works best. I think, and like do a cost-benefit analysis, right? So like things like LoRa may save you a few like computational cycles, but then like, is it comparable in terms of work? So I think it depends on like what your specific use case is.
Yeah, so I was thinking about adding, optimizing our models to be able to perform in several tasks. One is reasoning, another might be like being funny, and etc. And so we can have different sets of weights for different modality, and not modality, different states that our model is tasked to be performing well. And then we can then have another phase of training that our model can, based on the input, can distinguish, well, now it's time to be funny, now it's time to be reasoning, now it's time to be doing code. So I was thinking something, maybe we can do something like that. Yeah. So this is you imply this is an active research, and we don't know an answer.
Yeah, I think like, I mean, a lot of this is like active research. So like, it would be wrong for me to say do it or not do it. I think like in research, my bias is like do it and see if it works. So yeah.
Great, thank you.
Of course. And thanks for the great question.
Thank you.
Hi, I think we need to take a break now, and Mina will be here, so if you have questions, you can go to her in person. Let's go for a 10 minutes break and come back for the RLHF practical session. Thank you.